Asteroids and near-Earth objects are a big part of our solar system. Science fiction writers and filmmakers love to create stories that involve asteroids, whether it is a collision with Earth or an asteroid mining colony. The problem with most movies about asteroids is they assume that there's this big thing coming towards us and we can just blow it up. In reality, the prospect of planetary defense against asteroids is far more complex. What if an asteroid was heading for Earth? What could we do about it? Unlikely as it may seem, it can happen. Asteroids are rocky fragments left over from the formation of the solar system about 4.6 billion years ago. Most of the asteroids orbit between Jupiter and Mars, whether Jupiter's gravity prevents them from ever combining into a larger body. There are, however, asteroids and comets that have been nudged by the gravitational attraction of nearby planets into orbits that allow them to enter the Earth's neighbourhood. They are called near-Earth objects. They are not yet well understood. They have only been tracked for a few years, and their orbits are usually very uncertain. It is difficult to predict how close an object will come to Earth, or where it will hit. One such asteroid that fits this description was discovered in 2004, and initially appeared to have a chance of hitting Earth on April 13th, 2029.
Any object that's classified as an NEO has an orbit that crosses Earth's orbit, which means it will one day collide with Earth. It will collide with Earth. It's not just maybe. It will. It's just a matter of when. You know, we have an asteroid headed towards us, discovered in 2004, December. The reason why this is important is the very first calculation showed it might have been like a 1 in 10 chance that it would collide with Earth on April 13th, 2029. This is the size of the Rose Bowl, this thing. And it would be the biggest thing ever known to hit Earth in recorded history. During human occupation of the world, this would be the biggest thing we would know. So better data came along and we learned it would not hit us then, but it could hit us the next time around. If it threads a keyhole, a very narrow set of orbits, if it has one of those trajectories, Earth's gravity on it would be just right to bend it in such a way so that 7 years later, it will hit Earth. So you want to make sure this does not go through the keyhole. So at some point, you got to sit down and pay attention, even if it's several in a million. So if it threads the center of the keyhole, it'll hit 500 kilometers west of Santa Monica.
Named Apophis, after the ancient Egyptian deity who embodied chaos, its estimated diameter is between 1,115 and 1,214 feet. Additional observations cleared up the concern of a direct impact. Apophis is expected to pass close to Earth in 2029, 2036, and again in 2068.
We have sort of top people working on this, and one of them is sort of a gravitational tractor beam, where if I'm the asteroid and this is the spaceship, you bring a spaceship close to the asteroid, and then their mutual gravity will want them to come together. But you fire some retro rockets to prevent that. And each time you fire the retro rockets, you're effectively tugging the asteroid out of harm's way, gravitationally. You don't have to tug it by much. You move it sideways a little, that amount continues to drift, and it will miss Earth entirely. So this would be a mission of the right timetable to design, build, and send to Apophis to save the Earth.
Recent measurement unveiled that this asteroid is drifting more than 500 feet per year from its expected position in its orbit. In some cases, acceleration, a change in an object's speed and direction through space, can help avoid a collision, which fortunately is also the case for Apophis. As of February 2021, the chances of impact during the 2068 flyby of Apophis are now less than 0.00067%. These observations, according to David Towan, at the University of Hawaii aren't easy to obtain and analyse. Factors such as the asteroid's distance at the time of observation, its composition, its shape and its surface features all affect the outcome. The most important observations of Apophis will come during its close Earth flyby in 2029. Scientists around the world will have the opportunity to study the asteroid's size, shape, composition, and possibly even its interior. An asteroid impact on Earth would have catastrophic consequences depending on the composition of the asteroid and the location of impact. An asteroid is likely to make a crater upon impact with Earth, causing massive destruction within a radius of hundreds of miles. The crater is likely to be hazardous for some time following the impact. Moreover, a major asteroid collision would cause general disruption to climate and weather systems on Earth. Small objects frequently collide with Earth. Asteroids larger than 0.6 miles diameter strike Earth every 500,000 years on average. Large collisions, within 3 miles objects, happen approximately once every 20 million years. At the end of the Cretaceous period, 65 million years ago, an asteroid hit Earth at the Yucatan Peninsula, Mexico. This impact caused a mass extinction in which 75% of plant and animal species on Earth became extinct, including all non-avian dinosaurs.
Here's one about the actual size that would have taken out the dinosaurs. The one that took out the dinosaurs is about the size of Mount Everest. And obviously you're just dead if you're standing where it hit. But it killed all the dinosaurs. 70% of all species on Earth went extinct after this thing hit. So our first indication that local phenomena can create global consequences climactically was gleaned by the computer models that analyzed this.
Unlike the dinosaurs, we have a space program, and there are a number of telescopes dedicated to the task of finding new asteroids. Specifically, these instruments are geared towards finding any asteroids that cross the Earth's orbit and may therefore pose an impact hazard. In 1908, a small asteroid is thought to have exploded over Tangsuka, Siberia, which flattened trees over an area of 830 square miles. It is classified as an impact event even though no impact crater has been found. Scientists think that the explosion must have been caused by an iron meteorite about the size of a football stadium, which passed through the upper atmosphere, heated rapidly, and then passed out into the solar system again. The shockwave from this trajectory was what flattened trees. This was a lucky near miss for Earth, a direct impact with an asteroid that would leave a crater 2 miles wide and would have a catastrophic effect on the biosphere, perhaps even ending modern civilization. NASA and the Space Guard Foundation have discovered approximately 10,000 asteroids to date. There are estimated to be many 1,000 times more, all orbiting the Sun between the orbits of Mars and Jupiter, with the vast majority of them posing no threat to Earth. At any given time, there are at least 500 NEOs being tracked by various observatories on Earth. According to Neil deGrasse Tyson, if an asteroid is found to be on a collision course with Earth, instead of trying to blow it up, the main goal would be to nudge it out of its path, avoiding an unpleasant end to civilization. Avoiding a collision with an asteroid is not as simple as it may seem. An asteroid's orbit may be very precisely calculated, but its mass is not. It might appear to be just a few dozen feet in diameter, but it could actually be a mile wide. To reduce the threat from NEOs with orbits that will intersect Earth's, NASA has brought together an international team of scientists to develop a plan that will deal with both known and potential NEO collisions. It is considered to be the top priority for the agency's near-Earth orbit observation program. Today, no known object poses any threat to humanity, but many remain undiscovered, so we need to keep searching.